Alright, so hopefully I've got this. I want to go over a few things with the foldable. Okay, this one. So I added a couple of things to it. I wanted to point out that cliffs go above the ground, so I'll put just YI initial, like up, and then I put that your final, Y final is 0, just to kind of show that the cliff falls down. Also, on the range, you can assume that XI is 0, and then XF is wherever it lands. So just you're going from 0 to positive here, and you're going from positive to 0 on your Y direction. All right, so let's see. All of this should be done. I wanted to explain, I had a few questions about these equations and why this happened. If you notice, AX is 0, because you're in free fall and your velocity or your acceleration is only down, gravitational acceleration. So basically anything that had an A in it, an acceleration in a kinematic equation, went away. And also, since your acceleration is 0, that means your velocity is constant, so both your final and your initial velocities are Vx. So that's why this says Vx equals Vx. And then since the AT went away, Vx equals Vx, well, duh, that goes without saying. Same with Vx squared, Vx squared. On this one, if I rearranged the XF and XI, you get the range. I want to point something out. This is linear. You know, because the highest exponent t is to the first power. It's like a line, so that's linear. Keep that in mind. Okay, on this one, your initial velocity is 0. I think not as many questions on this one, so I just canceled out anywhere I had initial velocity. Okay, I want to explain why there was a marble on this one. If you remember the marble drop lab, you've got h equals negative gt squared over 2. Well, h is just another way of saying displacement, and negative g is just like acceleration, right? So if you rearrange this, you might remember from the marble drop, you have acceleration equals 2s over t squared. So that was, if you recall, that's how you found the acceleration due to gravity in the marble drop lab. Okay, so the graphs. Oh, I also want to point out that this equation right here, see how it's to the second power? It kind of looks like all curvy, quadratic-y. That is a quadratic second order polynomial. All right, on your graphs, got x versus t. Something a lot of people don't realize. You know that slope is rise over run. Or you could say your output over your input. So if you look at this, run or input are in the denominator. So if you look at your graph, it's kind of like time is your denominator for everything. So look at this equation. R equals Vx over t. Range equals velocity in the x direction times time. Anytime you have a kinematic equation and you can get time or something like that into the denominator, it'll probably help you with a graph. So I'm just going to t, cancel it out. That gives me range over time. And remember, range is changing your x position right here. So if you look at this range over time, well, it's positive because we don't have a negative. And if you recall, your original x position is 0. So you would start here, and then you would go positive. Also, something a lot of people, and I should have mentioned this earlier, you do the dotted line. This is because all of these graphs are for one thing that happened in one interval of time. So you want to make sure your times line up, and I'm going to put time final. That's when you stop looking at it. So that's your range. Quick review on this. You start off with a hill. See? There's just like the original landscape of a place. And you can say you got positive hill, kind of rolling up a hill to the top, or then rolling down the hill, negative. Then after that, you build a house, and it's a really weird house shaped like a pyramid. You don't need this line. And then, so it'd be like positive part of the pyramid, negative. Then after that, unfortunately, it gets bulldozed towards a parking lot. And then after that, it sinks down to the bottom of the ocean. Imagine ocean waves. The line on the graph shouldn't look squiggly like that. Just forget that. This just sinks down to the bottom of the ocean. Look, 0. bottom of the ocean, it's the 0. Okay, so this will help you kind of remember how functions go. So if I have this line right here, it's positive. Which one does that look like? Well, it kind of looks like the pyramid in a positive direction. So the next one down will be flat, and it would be positive parking lot, flat. See, so it means since it's positive, it won't go in the 0, it won't go in the negative, it'll go up here in the positive. So then what happens? It sinks down to the bottom of the ocean. So that means it just goes to the 0. It doesn't go below the 0, it just is on the 0. The way I do that is I make sure it's really dark on the 0, and then I usually write a 0 next to it. Okay, so that's how you do your graphs in the x direction. Now let's look at any kind of equation you have in the y direction. Take this one green. Okay, you got the, actually have that marble one. You have h equals negative g t squared over 2. And you can rearrange this to where you have the t squared on the bottom, but that's okay. See this negative? That tells you that you're going to be going in the negative direction. Also, you fall down. Really, seriously, you fall down, guys. Okay, and if you look back at your drawing, let's look at where you start off at. See why? Because you're going to fall down to the ground. You start off at a positive y. So that means on this graph, your y, you're going to start positive. Doesn't really matter where. Actually, I think I'm going to start it like a little bit higher. And you're going to have a quadratic that is negative. So it's going to look like the down portion of your hill. So it's going to go like that. And here is kind of a trick just for projectiles on the y versus x graph. See this? It looks like your trajectory on your of your projectile. So the y versus x for just projectiles, that graph slope looks like the trajectory. So if that's a negative hill, next we would go to negative house. But let's first look at your initial velocity in the y direction. If you will recall, that is 0 because it's all horizontal. Velocity to start off with. So we would start at 0. Then you would go to negative. I forgot to draw my time final. Okay, so that is negative. Now, then after that, you go to a parking lot, and since we're negative, it would be a negative parking lot. And that would be negative 10 meters per second squared, or negative 9.81 meters per second squared if you're on Earth. But do not assume you're on Earth. You might not be. Just make sure that's been stated or you've written that you've assumed that. Hopefully this helps.